Hi guys, good afternoon. So in the last session we finished with OSPF. Today let's start with BGP. That stands for Border Gateway Protocol. Now what is BGP? It is an interdomain mapping protocol. It is interdomain mapping. It is used between different ASS. Then it uses path vector. Okay. What else? See here. First of all, why BGP protocol is there? If we talk about BGP, right? So we can say BGP is a exterior gateway path vector protocol that is used to provide communication between different years. Can also provide communication within same years also. Okay. So, but majorly it is used for different years. So we can say most of the internet communications are happening over BGP protocol. Okay. Now BGP is known for its scalability. Okay. BGP is known for its scalability. Okay. Now, when I say scalability, what does it mean? So, scalability means the number of routes in a routing table are used, and your IGP protocols they cannot support these many routes. So, you will say BGP is a highly scalable protocol that can handle a huge number of routes. And the current BGP table, okay, the current BGP table has over 8 lakhs routes, 8 plus only. Those also after aggregation. Okay, so your IGP protocols they cannot handle these many routes. Okay, the IGP protocols cannot handle these many routes. This is clear. Okay. Now, like I said, BGP is a path vector protocol, and to decide the best path, it uses attributes. Okay, to decide the best path, BGP uses attributes. Okay, and your BGP protocol it's rich in attributes. That means multiple attributes are there. BGP is rich in attributes. So it uses like 12 to 13 attributes. Okay, so if we talk about your BGP attributes, if we talk about the BGP attributes, so the first attribute is next stop reachability. First, BGP will check for the next stop reachability. Next stop reachability. Then, number two, wait. Number three, local preference. Then, after local preference, forward. Huh? AS path. Before AS path, there is something else. Origin It will come later. Proceed. Locally injected routes. Then it will check for AS path. Then it will check for, and it will check which AS path, least AS path. Then origin. After origin, MED. After MED, neighbor type. And in the neighbor type, always your eBGP is preferred over iBGP. Then IGP, non-matrix. After that, always eBGP route. Then hmm, least neighbor ID. That is least neighbor ID. Then least neighbor interface ID. Least neighbor interface ID. So these are 3, 6, 9, 12. These are the 12 attributes. So if you are from enterprise, you have to remember all of them. In the interview, they can ask. Okay. Neighbor ID. Neighbor ID and router ID, same thing. Clear? Okay. Let me open the book. It should be there. Okay. So BGP works on TCP port number 179. Note it down. BGP works on TCP port number 179. BGP works on TCP port 179. Then blueprints. This book is not very well formatted. Passages, neighbor states. Okay. Then autonomous system numbers or ASNs. Now we know what is an ASN. ASN is a collection of routers under a single organization's control or under a single administrative domain. Okay. And BGP can use one or more IGPs and common matrices to route packets within a AS. Okay. So it can take help of your IGPs also. This is clear. Okay. Although an AS can use BGP as the only routing protocol, it is also possible that one AS has only BGP as the routing protocol. This is clear. Then, if we talk about ASN, right? So, an organization requiring connectivity must obtain an ASN. They must have an ASN. If they want internet connectivity, then they must have a autonomous system number. And the ASNs initially they were 2 bytes only. Okay. Initially they were 2 bytes only, which was making it possible only how many ASNs? 65,535. But due to exhaustion, RFC 4893, this expanded the ASN field of what is the new size? 4 bytes, or you can say 32-bit. And now how many possible ASNs are there? 4.2 billion. Yeah. Okay. Now, out of these, same like in the IP address, we have private and public concept. Here also we have the similar kind of concept. So there are some ASNs which are reserved for private use, like ASN 645122, 65535, and ASN this to this. So in the 16-bit range, these are the ASNs reserved, and in the 32-bit range, these are the ASNs reserved. This is clear. So this is about the autonomous system. Now, see here, it's not like only private, then rest of everything is public. No, that kind of thing is also not there. There are some reservations also. Okay. So what are the reservations? If we talk about the reservation, so take a look here. I think here we will have it. The table is there. One. BGP routing questions. Directly states are there. No prevention directly. Just a minute. Routing distribution, internet connectivity. Okay, note down these differences also. There is something called as NLRI. Okay, network layer reachability information. So the routing updates in your BGP, they are known as what? Network layer reachability information. So first thing you will note down is what? Like if you want, you can note down this entire table itself. That what is the difference between these IGP protocols and the BGP. So they also form neighborship before sending the routing information. BGP will do the same. Okay, here what is happening? The neighbors typically discovered using the multicast packet, right? So here we are using what? Multicast packets, and we are looking them on the connected subnets. That means generally in the OSPF and EHRP, we have seen that the primary subnet should be common. But here, first thing is you have to explicitly configure the neighbors. There is no automatic discovery. Okay, we have to be automatically, we have to explicitly configure the neighbors, and they may not be on the common subnet. It is not a requirement now that, okay, the neighbors have to be on the same subnet. Only reachability should be there, then neighborship can be formed. Clear? They do not use TCP, they are separate protocol, while this uses a TCP. And what is the port number? 179. Here they advertise prefix length. Normally we call them as a route or routing update. Here, the advertised prefix length, this is known as what? Network layer reachability information. This is clear. Then they advertise metric information. Here, what is happening? Variety of path attributes. Okay. Then emphasis on fast conversions. Okay. They focus on fast conversions. While BGP is mainly focusing on scalability, might not always choose the most efficient route. And these are like link state or distance vector, and this is what? Path vector, which is kind of similar to your distance vector only. So these many differences you can note down, these four differences or four or five differences, that they do not use TCP, these use TCP. Okay, so this is like how you can write down, you can say IGP and BGP. IGP protocols and BGP protocol. These are the differences. Like how you can note down. I'll leave some space because there is a table that will show you reservations for ASNs. Okay, these many differences you can note down. Okay. So BGP also use the term network layer reachability information to describe the IP prefix and length. Okay, same thing. That means the routing update only or the route only is the NLRI. Then the ASN. So since internal, external. We'll come to it. Yeah, this one, public and private ASN. This table here. Okay, that how the ASNs are assigned or what are the reservations. So ASN 0 is reserved, ASN 65535 is reserved, and ASN 64496 to 64511, these are reserved for only for documentation use. Okay, and remaining are the public and private only. Yeah. So that means if you want to remember, these ASNs, you just need to remember these two. Remaining everything is public except first and last. So you can remember like 64496 to 64511. They are used for documentation, and then the private ones. That's remaining everything 1 to 64495. These are what I know public ASNs. Okay, these are the public ASNs. Okay. Now, if we talk about messages in BGP, how many messages are there? Code, what are this? Open, keep alive, update, and notification. So, what is the open message? To establish the neighborship. Okay. Then, what is the keep alive message? Maintain the neighborship. Okay. So, it's kind of hello message only. Then we have update. Exchange the routing updates or the NLRI information. And what is the notification? If there is an error, right? So if there is an error, then notification will be sent. Clear? Okay. So this one we can say like difference between IEP and ET. In short, BG. Now under the IEP, we are talking about OSPF and PHF. Okay. Now, BGP messages. Part of not part. See, sometimes this question is asked in the interview. So about IP address assignment. So these are the 4 steps that you should understand. That first of all, ICN and INA, they will group public IP addresses by major geographic regions. These are the 2 organizations which will group the public IPv4 addresses by major geographic regions, and then they will allocate these to the regional internet registries. Okay. These INA and ICANN, they will assign to regional internet registries, then they will assign to national and local internet registries, and then finally the internet registry. They can assign further range to the customers and users. So you see the ISPs are what? Local internet registries. Here, this is how the entire IP address assignment process is. Route aggregation, BGP basics. Yes, internal messages. The old books are good, but they have a lot of extra information. Yeah, these are the messages. So if we talk about BGP message type, In BGP, we have four types of messages. Number one, open. Number two, keep alive. Number three, update. Number four, notification. Okay. And this is the information about the message. So if we talk about open message, this is used to establish neighbor relationship and exchange the basic parameters like ASN, authentication values. All these things will be shared in the open message. Then keep alive. So this is the message that is sent on the periodic basis at regular intervals. Okay. And how frequently this will be sent? Every 60 seconds. Okay. So if we talk about the default keep alive timer, it is 60 seconds and there is a hold interval also. That is 3 times, which is 180 seconds. Okay. So the default keep alive is 60 seconds. Okay. The default keep alive timer is 60 seconds and default hold time is what? 180 seconds. Clear? So this will be sent on periodic basis to maintain the neighbor relationship. And the lack of receipt of keep alive message within a negotiated hold timer, which is 180 seconds, will cause BGP to bring down the neighbor connection. That means every 60 seconds, I'm supposed to receive a hello message or the keep alive message. But if I'm not receiving within 180 seconds, then I'll consider neighbor is down. So we will bring down the neighborship. Then update. So update is used to exchange what? The path attribute information, right? Associate and the associated prefix length, which is network layer reachability information. So that means you can say this is used to exchange the routing updates. Okay, simply you can say this is used to exchange the routing updates. Then we have notification message. So in BGP, if there is any sort of error, then notification message will be generated. Okay, so this is used to signal a BGP error and typically result in a reset to the BGP relationship or the neighbor relationship. Okay, now in other protocols like AGRP, we have hello messages and we have update messages, but there is no direct equivalent to the notification. There is no such message that will indicate any sort of error. This is clear. Otherwise, if you want to discover neighbor or you want to establish a neighborship, in that case, hello message is there. And as a keep alive also, hello message only works there. And to exchange the routing update message works there. But there is nothing to define an error. Clear? Okay. So the messages are clear. If the messages are clear, then we can understand about the neighborship states. Okay. So let's talk about the neighborship states. Online people, this is clear. Any doubt so far?
No, sir.
So let's talk about neighborship state. No. Because TCP, right? It doesn't require separate acknowledgement message. So BGP neighborship states. Now, take a look here. These are the states. Okay. We have active. These are not in total. We have few more from here. Okay, we have idle, connect. After these two, we have active, open send, open confirm, and established. Okay. So first, let me paste all these here. And then we'll Okay, these are the states. So first one is idle. Idle means the BGP process is down. There is no BGP process itself. Okay. So either the BGP process is administratively down or it is waiting for the next retry attempt. Okay, that means maybe there was a problem in the connect state, so it came back to idle. So it is waiting for the next retry. Then after connect state. So in the connect state, what will happen? The BGP process is waiting for the TCP connection to be completed. That means it is trying to attempt for a three-way handshake. It is trying to establish a TCP three-way handshake. And you cannot determine from this state information whether the TCP connection is completed or not. Because if the TCP connection is completed, then it will go to open send state. If TCP connection is not completed, then it might go to active or idle. Okay. So in the active state, what it says that the TCP connection has been completed, but no BGP messages have been sent to the PM. Now here it says that okay, might be the TCP connection is completed. So this is one scenario that there is no BGP messages sent. But sometimes what will happen that if there is a problem in the TCP connection, like there is something called as finite state machine. Okay, if you will take a look, there is something called as BGP finite state machine. Plus one. This is the BGP finite state machine, which is explaining, the transition from one state to another state. It was published message session. Okay. Now if you see, right here it is saying that there is a possibility that the TCP handshake has been completed. But if you see a more detailed explanation here, that in the active state, the BGP starts a new three-way handshake. Because might be there is a possibility that TCP handshake was not successfully completed. So it will start a new three-way handshake. That means it will retry. Okay. And if a connection is established, then an open message will be sent. Okay. And then what will happen? The hold timer will be set to what? 4 minutes. Rather than 3, it will be set to 4 minutes. And what will happen? The state will move to open send. And if this attempt for TCP connection again fails, then the state moves back to connect state and reset the connection retry time. So that means here also there is a possibility that it will try for TCP three-way handshake again. This is clear. So if it is established, if the TCP connection has been established, then what will happen? It will go to the open send, and if not established, again it might go back to connect. Is that clear? Okay. Then we have the open send. So in the open send, as the name suggests, the open message has been sent. Okay. The open send state. An open message has been sent from the originating router and it is waiting for open message from the other router. That means one router has sent the open message, the other router, and it is waiting for the other router to do the same thing. Yeah. So when the originating router receives an open message, if the neighbor also sends the open message, open confirmed state will be there. Okay. So from the other router, both open messages are checked for errors And what are the things it is going to check? It is going to check whether the BGP version is same or not. It is going to check whether the source IP address of an open message is matching the IP address that is configured in the neighbor statement. See, in BGP, what happens? That how do we configure the BGP? Like basic configuration, if we talk about. Let's say these are two routers. This is R1. This is R2. So how do we configure it? Let's say again we are using the network something like a /24. And here let's say 192.168.12.1, 12.3. So on R1, if you want to configure BGP, how you will configure? Router BGP, then ASN, then what do you say? Neighbor, and what do you say? Neighbor ID. Then you will say remote AS, and you will give the ASN. To which ASN it belongs. So it is saying the source IP address of the open message. That means whatever the open message this guy is sending, the source IP address of that message should match the IP address I have configured in as a neighbor. Is that clear? Whatever the open message this guy is sending, so the source IP address of that message should match the neighbor statement. If it is not matching, that means you are not my neighbor. Same thing, AS number also. Here we are configuring the AS number. So whatever the AS number this guy will send in the open message, that should match with this. Then the BGP identifier, that means the router IDs, they must be unique. Then the security parameters, like if you have configured a password or TTL, they must be set appropriately. These are the parameters, or you can say these are the neighborship criteria in BGP. In BGP, you can say these are the neighborship criteria. Is that clear? Okay. So what I'll say here, wait for it. So as of now, what we need to understand that in the open send state, the open message has been sent and we are waiting for the open message from the neighbor. And then in the open message, these are the parameters that will be matched. So for going from open send to open confirm, these are the parameters must match. If the open message do not have any errors, the whole time is negotiated to a lower value using the lower value and the keep alive message is sent. Okay. And the connection is then moved to open confirm. And if there is an error, then you see notification will be sent and the state is moved back to idle. Here. Okay. Then open confirm is there. So in open confirm, what will happen? The BGP will wait for either a keep alive or notification. If keep alive came, neighborship established. If notification came, go back to idle. And established state, that is the final state. That means the BGP session is established and they will start exchanging the routes through the update messages. Okay. So here, as update and keep alive messages are received, the whole timer is reset, and if the whole timer will expire, error will be detected, and BGP will move back to idle state. Now look at the finite state machine. This example. Initially, it is in the idle. In the idle, there is no three-way handshake. Then it will try to establish three-way handshake here. So in the three-way handshake, what will happen? If there is a problem, it might go to idle or it might go to active. In the active state, it will try again to establish three-way handshake. So if three-way handshake is successful, then what will happen? It will send open message and it will go to open send. Okay. And if three-way handshake is not successful, it will retry. And if still no, it can send to the connect state again to try to establish a new three-way handshake. If nothing works out, finally it will go back to idle state. And in the open send state, what will happen? That I have sent the open message. Now I'm waiting for an open message from the neighbor. Right? So if I receive an open message from the neighbor and all my parameters are matching, I will go to open confirm. And if the parameters are not matching, I'll go back to item, right? Let's say parameters are matching. We are in the open confirm state. In the open confirm state, we are waiting either for a keep alive or a notification. If I receive a keep alive, it is established. If I receive a notification, go back to idle. So if I'm established, again, I will have update messages and keep alive messages. So if I receive keep alive and updates on time, no problem. I will remain in the established only. And if I receive a notification, go back to idle. This is the finite state machine showing that transition. This is clear. Online people, any doubt?
Yes.
Okay. Now, one thing we have to talk about the parameters, right? So let's note down those all parameters that for going from open send to open confirm state, the two BGP peers must have following criteria mapped in the open messages. So what are the criteria? So if we talk about the criteria, these are the ones. Note it down. Note it. Now, see, we saw that okay, from connect state, your BGP neighborship state can go to the active state. So there are two possible reasons for why like this thing can go in the active state. So what are the reasons? So note down. The BGP neighborship state can go from connect state to active state for the following reasons. So what are the reasons? Number one, there is a routing issue. Number two, TCP port is blocked. Right? And number three, there is a possibility that ACL is there. So ACL is blocking the traffic. These are the reasons. These are the common reasons that your neighborship state will go from connect to active. Okay. Not it. Then we have two types of BGP, right? So if we talk about BGP flavors, what strawberry vanilla? So we have two types. One is the IBGP, which is known as internal BGP. So this provides communication, responsible for providing communication within an AS. Okay. And we have eBGP, which is external BGP. Responsible for providing communication between different AS. Okay. Now we'll see about the configuration. What is the basic IBGP configuration? What is the basic eBGP configurations? So first of all, let's talk about IBGP configuration. Let's consider if you have two routers, or let me directly type the configuration in lab. We will do it. So you will say what? Router, BGP, and ASN. Then what do you say? BGP router ID to configure router ID. And same router ID concept will remain same everywhere. This will be in the IPv4 format. Then you will configure neighbors. So neighbor IP, remote AS, and here you will give the ASN. So since they are in the same AS, so this ASN will remain as it is. Then we will, if you want to advertise network, so you will say network ID. And then you will say mask, and you will say subnet mask. Now, technically, if you see, both configurations are same. IBGP or eBGP configurations are same only. Only this change, this thing will change. The ASN. Huh? Same thing, right? This will be the same thing. That means you will give the neighbor's IP, and IP is what? An identification only. Okay. All right. Now, and if you look at eBGP configuration, right? EBGP configuration. So here this ASN, we just have to make sure that this ASN is what? This is neighbor's ASN. That is only the difference. Remaining everything is as it is. No change at all. Clear? So only one difference. Router, BGP, and here you will give what? Self ASN. That means whatever the router, wherever you are configuring, what is the AS number of that router? Like we say router AGRP1. So that one is what? Self ASN. Correct? And then we will say that BGP router ID and whatever the router ID is there. Okay. Then you would say neighbor IP, remote AS, and here the ASN that will come, that will be for the neighbor. And then you will say network ID, task, and subnet ones. Okay, this is clear. Okay, now let's go to the lab and we will see it practically. Then we have to give explicitly router ID or implement the which one? Router ID. In here, you will have to configure. Okay. Otherwise, by default, you can use the interface. Like I said, router ID concept will remain same. Admin. About reflect configuration attributes. Flavors. Okay, look at this lab. So here we have both the things, IBGP and EBGP. Let's start all the nodes. Now, meanwhile, these are coming up. Let's configure the routers. Until the host name, we will cover from the loopback also. We can R1 IP address will be 12.1. Loopback is okay. BGP we will configure. R2, R2, take access of R1. Then R2. Paste R1 configuration. Okay, let's test the basic connectivity. Because for BGP reverse, reachability should be there. As I do ping 12.2, can see I have the reachability. Correct. Now, at the same time, we will also see, the BGP neighborship states. So I'll say debug IP. Do I have to use? Okay. Right now, I'm not configuring anything on R2. Now, what I'll do, I'll say router BGP1, or sorry, ASN is 12. So, router BGP 12. Okay. Neighbor, what is my neighbor's IP here? 12.2. 12.2. Then remote AS. And what is the AS? Same AS. So, okay, typo. Done. Now see here. Also, let's advertise an echo 1.1.1.0 255.255.255. Yeah. Now see here. The state is what? Went from idle to active because in the connect state, not able to establish a free will. Okay. See, the current state is active. Do show IP BGP. Do show IP BGP neighbors. Summary we have to see. Okay, let me show you summary on. Summary is not there. Show IP BGP summary. So you can see what is my state. My state is idle. Okay. All right. And if we capture the packet, capture G0 by 0. Okay, so you can see TCP packets going from 12.1 to 12.2 and trying to connect on port number 179. But BGP is not enabled, so the target is not accepting anything. So that's why it is sending what? Reset. The R2 is sending what? Reset. Why? Because their BGP is not enabled. So it's not listening on the port number 179. This is clear. Now, let's go on R2. If I go on R2 and if I say router BGP to out neighbor IP is 12.1, remote AS is 12, network 2.2.2. You see neighborship is up 2.2.2.0, 255, 255, 253. Already my neighborship is up. No, not 25. Something is wrong. Yes, mask, sorry. I consider it IP address. Okay, so you can see my neighborship is up. And if we take a look now, that okay, how did it go up? So earlier it was from idle to active. Then what happened? Sent open message. So when it sent the open message, the state went from active to open sent. Then in the open sent, what happened? It might have received the open message later on. Okay. So let's see. See, receive open. Okay. So after that, it should go in open confirm. You will find it out somewhere. See here. Went from open sent to open confirm. And in the open confirm, it might have received a keep alive. So once keep alive was received from open confirm to stop. This is clear. Okay. And now if I check show IP BGP summary, so the status, like right now it's not showing. That means it is established. Clear. And if we look at the packet capture, we can see that we need first of all TCP and we need BGP. So you see open message, then keep alive. Then there was update message. Inside the update message, if you take a look, so this was the update message. Okay. This is again update message. Then they are exchanging what? Keep alive. Okay, so here we are not able to see the information. Okay. The information is not visible to us, but they have exchanged that. These are the keep alive messages. So in keep alive also, we don't really have much information. Okay. And if I look at TCP only, so if we take a look at only TCP messages, wait for it, it's filtering. Now take a look, earlier it was sending reset, right? Then after suddenly we had the three-way handshake. And once three-way handshake was completed, the open message was sent. Correct? After the open message, again acknowledgement. Do you see again open message? So this was the first open message coming from 12.1 to 12.2. The second open message came from 12.2 to 12.1. Both open exchange. Open exchange means open confirm. In the open confirm, again from neighbor what was received? Keep alive. And once keep alive was received and the neighbor also received keep alive, they went to the established state. Once the established state was there, they started exchanging the update messages to exchange the routing information, right? So see here, people I was continuous and they exchange the update messages, and with the help of update messages, they exchange the routing information. This is your entire BGP flow. This is clear. Neighborship states also clear, practically seen. Okay. Online people, any doubts so far? Yes or no?
No, sir.
Okay. Now, next thing is, let's say about eBGP configuration. So let's close this one. And now we don't need these. Now, R1 is in ASN1, R2 is in ASN2. Okay. Now, if we take a look at the configuration, so we don't have much change in the configuration. Just BGP configuration, ASNs will change, nothing else will change, right? Copy. Hmm? How? In the update messages only. The update messages are used to exchange what? The network layer reachability information. So in those messages only, we will exchange. And this is R1 like this. And copy the R1 config or R2 config. Okay, R1 is already pasted. Done. Let's check the basic reachability. Reachability is there. Now, same thing. Router BGP, here we will have self ASN. That means I'm configuring on R1, so here it will be R1's ASN. R1's ASN is 1. Okay. Then you can configure BGP router ID if you want. Let's say 1.1.1.1. Neighbor we can configure. Let's say neighbor is 192.168.12.2 and remote ASS. So what is the neighbor's ASN right now? R2 ASN is 2. Then I will say network and mask. Then here also we can verify. Do debug IPDGP. Now here again, this will go to which state? Active state. Okay. This will also go to active state. See here, idle to active. Okay, and same thing we will see here also if I go and capture the packets. If I'll go in and capture the packets, so the R1 is keep on sending SYN message and R2 is sending what? Reset acknowledgement. Okay. See, R1 is sending SYN and R2 is sending reset acknowledgement. Clear? Now let's go and configure on R2 itself. So if we go and configure on R2, router, BGP, self ASN, R2's ASN is 2. Then let's say BGP, router ID. Router ID is let's say 2.2.2.2. Then neighbor IPs 12.1. Then remote AS. And the remote ASN, that means R1's ASN, which is 1. And we can say network mask. You see the keep alive and update and everything, all the messages have been exchanged. Now what happens? Here. Now everything has been exchanged and we can see here verified that there was a 3-way handshake, successful 3-way handshake. Then after open message was exchanged, acknowledgement was given, open message was received, keep alive received. That means open confirm, after that keep alive, so established, and after that update messages. Yeah, this is clear. So now they will keep on exchanging only keep alives. That's it. Clear? Every 60 seconds, keep alive will be there. Okay. And if we take a look at the states, and one thing you can notice here, even keep alive messages are being acknowledged here. But that is using TCP acknowledgement, not the BGP acknowledgement. Okay, this is a TCP acknowledgement. Okay. Then if I take a look here in the R1, so in R1 also we can find out all the states again. So this was idle to active, then open message was sent. So state change from active to open sent, then it received some open messages, right? And after receiving the open messages, the state changed. Okay, the state changed from open sent to open confirm, then keep alive was received, so open confirm to established. Clear? Okay. And we can check to show IP route. Show IP route BGP. Nothing. And if I say show IP route, sorry, show IP BGP summary. So you see neighborship is up. AS number is 2, 6 messages received, 6 messages sent. Okay. Then show IP BGP. Nothing is here. Okay. So, import detail. Neighbors, we can see neighbors we have seen. Summary we have seen. Okay, so if you want to take a look at the neighbors in the detail, this is the neighborship. This is the neighbor, this is the router ID. Okay, the state you can see here. Now, when you look at there, it will not show you correct state, but here you can clearly see the state. Okay, how long it has been up, what is the hold time, what is the keep alive interval, all those informations is visible. This is clear. Okay. So basic basic IBGP and EBGP configurations are clear. Yes or no? Okay. Online people, is it clear?
Yes, sir.
Yes.
Okay. So let me stop the debug. Now, next topic is about the loop prevention mechanisms. Okay, so we have to know about IBGP and eBGP loop prevention mechanisms. So note it down. Okay, two things. So we'll not be able to complete it right now. So as of now, you take them as a task. What do you have to search today? IBGP, loop prevention mechanism. And same thing for eBGP as well. eBGP, loop prevention mechanism. These are the two things task. Okay, clear? Okay. Right. To show run 5 section. Show run. There it is. We have advertised, right? Section BGP. This side also we have advertised. Wait a minute. Say no. This one also. One, last 2, 5, 6, 5. Network 2.2.2.2. Wait for it. Do right. Do right. Issue until route. Okay. Hmm. It's visible, right? And same way, if you say do show IP BGP, so here also it will show you valid and best group. Okay. And here this is next of 0000. That means what? Default. This is local route, directly connect. Okay. That is the case. And I think in the update messages somewhere here we will be able to see also. See, path attributes and the NLRI. Okay. It will be in the update message. Clear? Online people clear? Guys, clear, right?
Yes, sir.
Okay. All right, guys, then that's it for the day. So you guys will check about loop prevention mechanism for IBGP as well as eBGP. Okay. Okay. All right, guys. Then see you guys tomorrow. Have a good day. I mean Monday.